So let me show you how I did this. So let me rewrite the answer again and then show you how I did that. So from here I have what? 1 over 8. Okay, then we have what? 2x plus 1 exponent what? 4 plus what? So actually you could do this in less than 60 seconds. Okay, you could actually solve this question in less than 60 seconds. So let me show you the secret trick I use. Hello everyone, and then welcome to another tutorial video. So in our previous video we took time to take or treat definite integrals. Okay, so we got to know the introduction to integration, how to simplify or find the integral of simple expressions. Okay, and then we went on to find what definite integral. So in this video we'll be using what or studying how to integrate by substitution. Okay, so that's per the titles, integration by substitution. Right, so in case you are new to this channel, kindly subscribe to the channel, turn on your post notifications so that you don't miss out on future videos. Like the video, and in case you have any questions, just let me know in the comment section and then I'll reply to them as soon as possible. And then it will be helpful if you try sharing to your other colleagues or classmates, okay? Because this video entails a lot. Okay, I'll be sharing with you some tricks when it comes to what integration by substitution. Right, so let me just proceed from there. So you know that what integration by substitution is all about substitution. Okay, so let's say you come across any integration or integral in this format. Okay, so you have the integral sign and then you have what f prime of x multiplying what f of x, and then we have what all raised to the power n. So that's what f of x raised to the power n dx, or you come across what an integral of what f prime of x divided by what f of x all raised to the power n dx. So f prime of x, okay, is all about what differential, okay, or differentiation. That's why initially, if you've watched my previous video on what integration or introduction to integration or definite integral, I mentioned implementing differentiation in what integration. So we fuse them together. Now let me show you something unique over here. So when you come across maybe a certain integral, okay, of this format, so maybe 2x plus 1 exponent what 3 dx. Okay, so you can notice that this form of integral doesn't fall under any of these two types. Okay, so let me show you how you can easily solve this. So by just looking at this expression, I could just find the answer. Okay, so I could say that what the final answer is what 2x plus 1 exponent what 4 plus c. Okay, so you might be wondering how I came about with the final answer. Okay, that's why I stated initially that you need to stay with me till the end of the video so that you get to know how I was able to come up with the final answer for this question. Okay, very simple. Just stay with me till the end of the video and then I will show you how to come by these simple ways of finding the solutions to these form of integrals. Now let's proceed. So let's proceed with these form of what integral. So when you come across any form of integral in this format, first thing you need to do is just find what use your substitution. So you just take your substitution as what u. Okay, u equals what f of x. Okay, u equals f of x. So let's take an example so that you get to understand what I'm trying to say. So whenever you come across any expression in this format, it is what an integral. Okay, that's f prime of x multiplying what f of x exponent n dx, or what a fraction form. Okay, f prime of x divided by what f of x exponent n. So this is what the multiplication. Okay, that's the two multiply, and then this is what a fraction form. So let's take an simple example. Again, I will show you how to come by these solutions. It's very simple and straightforward. Just stay with me till the end of the video. So let's say we have an example. Let's say the integral of what the root of let's say 7x plus 4, okay, dx. So you can notice that this is not in this form. Okay, this expression is not in this form where you could just use simple approach. So it's in either in this form or this format, okay, but it's not in a fraction form. It's just simple what multiplication. The reason why it's just simple multiplication is that we have 1 over here, 1 multiplying this expression, but we don't write 1, okay. That's why we only have what, the root of 7x plus 4 and then ds. So let's find the solution to this question. So when you come across any integration of this format, the first thing you need to do is just use your what, the u substitution. So you have what, u being equal to what, 7x plus 4, okay. That's the first thing you need to do. That's why we have what, 7x plus 4. So initially I stated that you have to use what, f prime of x, and then what, you multiply that by the main expression. So this is how we do that. So first find what, du, okay, dx, du dx. So when you find du dx is all about what, differentiating u with respect to x, okay. So when you do that for here, you end up with what, only 7, okay, because when you differentiate 7x plus 4, you end up with what, 7, right? So from now, just you can notice that we have dx over here, okay. This is dx. So let's make dx the subject from here, okay. Let's make ds the subject from here. So when we make ds the subject from here, we have what, 1 over 7 du giving us what, dx, okay. This is very, very simple. Just follow what I'm doing systematically, and then you get to appreciate this concept. It is very, very simple, okay. Integral by substitution is very, very simple. Just follow me step by step and you'll be good to go. Now, after doing this, just substitute that expression to the same what, into the initial question. So we have what, root of what, 7x, okay, plus 4 dx, okay. Just do simple substitution. So we have what, the integral of u. So u is what, 7x plus 4. So let's replace that with u, and then we have what, dx. Dx is now what, 1 over 7, okay, du. That is dx over here, okay. That is dx over here. So we just proceed from there. We know that what, u, root of u is the same as what, u 1 over 2, okay. Then you multiply that by what, 1 over 7 du, okay. Very, very simple. Now you can now what, integrate, okay. You can now integrate. So when we integrate u exponent 1 over 2, you end up with what, u exponent what, 3 on 2, okay. You just multiply that by this one. So we have what, 1 over what, 3 on 2, okay, u exponent what, 3 on 2, and then you multiply that by what, 1 over 7 du, okay. This is just simple what, multiplication, okay. So when you do this simple multiplication, so this is all about what, 1 over what, 3 on 2 multiplying what, 1 over what, 7, okay. And then you have what, u exponent what, 3 on 2, and then you have what, du, okay. So this will give us what. So from here you can notice that since we are just taking the what, the integral, okay, you could just replace the du by what, the constant, which is c, okay. The constant, which is c. Just from here, when you do the simple multiplication, you end up with what, 2 over what, 21 u, okay, exponent 3 on 2 plus what, c. Then you end up with what, this. And then in simplicity, you can just simplify this. You just have to replace your u. So initially, you know that u is what, 7x plus 4. So you just replace that. We have what, 2 over 21, and then we have what, 7x plus 4 exponent what, 3 on 2 plus c, okay, because you know that what, u is already what, 7x plus 4, and then that is raised to the power of 3 on 2, okay. So that's the same thing over here. So this is the final what, solution, okay. That's the final. So notice that that's very, very simple. So I'll take another example so that we get to appreciate the concept. This is very, very simple, okay. Very, very, very simple. So let's try another example. So let's say you are given what, the integral of x, okay. Then you have what, a root of maybe 1 minus what, x squared, and then you have what, dx, okay. So you are told to what, integrate. You just use a simple approach, the same principle, okay. So you just have to use your substitution. So you have what, u equals what, 1 minus what, x squared, okay. So this will be our u. So let's find what du dx. Okay, so when taking du dx, we end up with what? Minus 2x. This is just simple what? Differentiation. Now let's make dx the subject over here. Okay, because of this, so we have what? Dx giving us what? Minus 1 over 2x du. Okay, so after that, just do your simple what? Substitution. Okay, you just substitute into the main what? Expression. So we have what? Let me just rewrite that over here. Just substitute that into the main expression. So we have what? The integral of what? Root of what? 1 minus x squared is already u, okay, from here. Okay, so just write your u. And then we have what? Dx. Now dx is what? Minus 1 on 2x. So we have what? Minus 1 on what? 2x, okay? Du, okay? Minus 1 on 2x du, because this, we are just substituting this dx with what? The dx over here. This is the entire of what? Dx. It's just simple substitution, okay? So from here, you could just proceed, okay? Now, from here, you can notice that x will just cancel s out. So we'll be left with what? Only root of u. And then you just multiply that by what? 1 over what? Minus 2. And then you have what? Du. Now, we know that u is already what? 1 minus s squared. The same principle, okay? Just substitute that. So we have root of what? So you could just hold on or just do it right away, but let's just hold on for now and just proceed with u being what? 1 over 2, okay? Because root is the same as what? Exponent 1 over 2, and then you just multiply that, okay, by 1 over what? Minus 2. You have du. So from here you could just proceed to what? Integrate. So as we take initially, we know that when you integrate u exponent 1 over 2, you end up with 1 over what? 3 on 2, okay? Multiplying u exponent what? 3 over 2, and then you multiply that by what? 1 over what? Minus 2 plus what? C, because we are integrating, okay? So from here you can just simplify this to give what? 1 over 3 on 2, multiplying what? 1 over what? Minus 2. Put that in bracket, and then you have what? U exponent what? 3 on 2 plus what? C. Right, so from here you could just introduce your what? U, and then just multiply this one throughout. So when you multiply 1 over 3 on 2 by what? 1 over minus 2, you end up with what? Minus 1 over 3, open bracket. We know that u is already what? U is already 1 minus s squared, so you just substitute that. So we have what? 1 minus what? S squared. Close the bracket, we have exponent 3 on 2 plus what? C. So this will be our final answer. Okay, this is very simple, very simple. So let's take the final example, and then I will show you how to use the simple approach to finding out the integral. Okay, right, so let's do that. So let's take the final example from here. Okay, so let's take the final example. So let's say you come across another integral in this format. Okay, so we have what? Maybe the integral of maybe sine of what? Maybe 3x minus 1, okay, dx. So note that you need to know how to find the integral for these trigonometric functions. I might not treat them, okay, I might not. So it's better to know how to integrate them. So let's say you have sine. If you integrate sine, what will you get? If you integrate cos, what will you get? Okay, when you integrate tan, what will you get? When you integrate cosec and all that, okay, right? So let's proceed from there. So let's see how you find the solution to this problem. Now again, just substitute your u. So you have u equals what? 3x minus 1, okay, that's our u. Let's find what? Du dx, okay, du dx will give us what? Just 3, okay, and then let's make what? Dx the subject. It's just the same principle, okay. So we have what? 1 over what? 3 du. So you just substitute that into this main what? Expression, okay. So now we have what? From here, from this expression, we have what? We now have what? The integral of what? Sine of what? U, okay, because 3x minus 1 is u, and then you just multiply that by what? 1 over 3, because you are substituting what? The dx, okay, you are substituting the dx with what? 1 over 3 du. Okay, so from here you could just rewrite this as what? Maybe 1 over 3 with the integral, okay, and then you have what? sine of u, okay, and then du. Now from here you could just proceed to take what, the integral of what, sine of what, u. Again from here, okay, you can just write this as what, 1 over 3. You just take that one out, and then you have what, sine of u, and then you have what, du. Okay, so let's take the what, the integral of what, sine of u. So when you take the integral of sine, you end up with what, minus cos. Okay, so you have what, minus 1 over 3, okay, and then you have what, minus what, cos of what, u, okay, cos of u, and then we have what, plus c, because we've already taken the integral, so we just replace everything, the remaining with what, the constant. Okay, you just do that. Now from here you could just rewrite this as what, minus 1 over 3, and then you have what, cos of what, u. We know that u is what, 3x minus 1, so we just replace that, 3x minus 1, and then you just replace or you just bring your what, constant. So this will be the final answer. Okay, so you could notice that I made this look a bit simple. Okay, very simple, so that you get to understand. Right, so now let's proceed to how to easily find what, the integral by substitution, by the simplest approach. Okay, the simplest. Okay, so initially you could notice that I just got this answer by just looking at the integral, okay, and just wrote the answer straight ahead. Now let me show you how you could do this. Okay, so let's retake the same problem again. So this was the problem. So we have what, the integral of what, 2x, okay, plus 1 exponent what, 3 dx. Okay, so let me show you how I did this. So let me rewrite the answer again and then show you how I did that. So from here I have what, 1 over 8, okay, then we have what, 2x plus 1 exponent what, 4 plus what, c. Okay, let me correct that. Okay, that's what, exponent 4 plus c. So actually you could do this in less than 60 seconds. Okay, you could actually solve this question in less than 60 seconds. So let me show you the secret trick I used. Now whenever you come across any form of integral, okay, in this format, and then you want to use the substitution approach, so you could notice that you could just see that we have what, this is the same as what, u, okay, exponent 3, okay, this is u, so replacing 2x plus 1 with u, we have what, u exponent 3. So in order to bypass the substitution approach, differentiating, integrating, and all that, this is what you need to do. So let me show you what, the simple approach. So this is a simple approach. So you have what, this integral, okay, is in this format. Okay, ax plus b exponent n dx. Okay, you can notice that you have 2x plus 1 exponent 3 dx. That's the same format over here, ax plus b. So a is what, 2, and 1 is what, b. Now whenever you come across any integral having this format, all you need to do is just use this simple trick. Okay, so it's what, 1 over what, a multiplying what, n plus 1, okay, and then you multiply that by what, ax plus what, b, okay, exponent n plus 1, okay, and then you add what, your c. Okay, you could add your c, that's the constant. So from here you can notice that this was what, 2x plus 1 exponent 3 dx equals what, 1 over 8. That's the answer. That's 2x plus 1 exponent 4 plus c. So now you can notice how I came up about with the final answer. This is the main question. Okay, so all you have to do is just use this simple formula. So you have 1 over what, a times n plus 1. From here you know that a is what, a was 2 over here, so 2, and then n plus 1, n was what, 3, so 3 plus 1 is 4, so multiply that by 2, you end up with what, 8. Okay, and then you maintain the same expression over here, but you just introduce n plus 1. You know that n is what, 3 plus 1 is 4, so that's how we ended up with what, this what, expression. So let's take another example so that you get to appreciate this approach. Okay, so let's take another example. So let's say you have the integral of what, this integral is so huge, so let's find what the integral, okay, of what, maybe 2x minus 5, okay, and let's say exponent 7 x. Okay, so let's use the same approach. So from here you could notice that we have what? 1 over what? A. So a is what? 2. Okay, and then n plus 1 is what? 7 plus 1, that's what? 8. Okay, so we have 2 multiplying what? 8, that's what? 16. Okay, and then we have what? The main expression, that's 2x minus 5, and then we have what? The exponent is what? N plus 1. So n plus 1, that's 7 plus 1 is what? 8. And then you can introduce your constant c. Okay, notice that this is very simple. You could choose to maintain the plus c or just ignore it, okay, because we've already found the answer. So let's take the final example, okay, and then we call it a day. So let's say we have what? The integral of what? Maybe 3x minus 5 exponent what? 12 dx. Okay, so let's find the final answer. So we have what? 1 over what? So we have 3, that's a, multiplying what? N plus 1. So n plus 1 is what? 12 plus 1, that's 13. So 13 multiplying 3 will give us what? 39. Okay, and then we maintain our what expression, that's 3x minus what? 5. And then you close the bracket. Now we have n plus 1. Okay, so n plus 1 is what? 12 plus 1, that's what? 13. Okay, 13. Now this will be your final answer for this question. Okay, so in case this video was helpful to you, I would urge you to subscribe to this channel, turn on your post notifications so that you don't miss out on future videos. Like the video so that it gets pushed to other students like you, just like somebody liked this video and then you are watching it right now. Okay, and then in case you have any further questions, just let me know in the comment section and then I'll reply to them as soon as possible. Kindly share, okay, share the video so that it gets pushed to other students who might need this video to help them augment their studies, okay, help them learn smart. And then I will see you in our next video where we'll be treating what? Indefinite integrals and then how to use a calculator to solve what? These kind of questions, okay. So I will see you in the next video. Have a lovely day.